Welcome everyone. So good afternoon, everyone joining in today, and welcome officially to day number 3 of Tech Week YQG, known as Mobility Day. So we are grateful to work with our partners at WeTech Alliance to bring you this informative session focusing on automotive cybersecurity. My name is Ed Dawson, and I am the Senior Manager of Automobility and Innovation at Windsor-Essex Economic Development Corporation. Our organization is proud to lead the Windsor-Essex Regional Technology Development Site as part of the Autonomous Vehicle Innovation Network. We'd like to thank the Ontario Centre of Innovation, OCI, in Avon for allowing us to sponsor today's event. The Windsor-Essex RTDS is supported by our regional innovation ecosystem partners such as WeTech Alliance, the University of Windsor, St. Clair College, and many others. The focus of our RTDS can be broken down into the following areas. First, cross-border technologies, because we host the busiest border crossing between Canada and the United States. Next, we are excited to have established Canada's largest publicly accessible VR cave designed for the simulation testing of CAV technologies and more. And of course, the focus of today is automotive cybersecurity. This is thanks to the Windsor-Essex region, long being referred to as Canada's automotive capital. Our region is home to over 1,000 advanced manufacturers, many of which have strong supply ties into the current and evolving automobility sector. It is inherent that the entire supply chain is organized and protected as vehicles continue to become more connected and eventually fully autonomous. For today's discussion, we have some very distinguished cybersecurity professionals who I will introduce just before we begin the panel. We will have time for a dedicated Q&A portion after the panel is finished. So please type your questions in the chat function anytime during the session, and they will be addressed during that time. I now have the privilege of welcoming Mr. AJ Khan, who is the CEO of Vehiqilla Incorporated, an automotive cybersecurity company proudly located in the Windsor-Essex region, to present an automotive cybersecurity overview. Welcome, AJ, and please take it away.
Thank you, Ed. Thanks for the introduction. And I do want to thank WeTech Alliance and Windsor-Essex Economic Development Corporation for giving me this opportunity. I do feel that the story of the growth of Vehiqilla is the story of automotive cybersecurity in Windsor-Essex region. So it is great to present our story and the story of automotive cybersecurity. I'm going to share my screen. I have a small deck. And I just want to confirm that my screen is visible.
You are good, AJ.
Great. So everyone, I'm AJ Khan. I've got 20 years of cybersecurity experience. And since 2017, I'm involved in automotive cybersecurity. And I am the CEO of Vehiqilla, which is headquartered in Windsor-Essex region. And when we start talking about the transformation of the mobility sector, obviously we start talking about the connected, the autonomous, security, and electric areas. Each one of these domains I know are something where a lot is happening in the Windsor-Essex region. But for us, of course, we are looking at security. And security is very important in the vehicle of the future, because the vehicle of the future needs to be adequately protected from cyber threats. You would notice over here that I have, in this image, I have put these bubbles around not the latest vehicles. These vehicles might be 10 years old as I'm seeing it. But what I'm saying here is, if you have a cybersecurity bubble around this vehicle, then it's a protected vehicle. And as we move forward towards connected and autonomous vehicles, then to get the benefits of the vehicle of the future, which include better traffic flow, less accidents, less impact to human safety, so better human safety, that is where cybersecurity comes in. So the question is, what does a vehicle look like and I'm saying the vehicle of the future, without cybersecurity implemented in it. We were talking about connected, autonomous, like driverless, electric vehicles. So for all those cases, if cybersecurity is not implemented in the vehicle of the future, what would it look like? Well, here's the vehicle. So that is the vehicle of the future without cybersecurity implemented. It is a connected vehicle. It is a driverless vehicle. In this case, especially, it is a driverless vehicle. But and it might be even be electric vehicle. But the vehicle of the future without cybersecurity uh, is not secure and cannot be driven and is not updated. But what about the vehicle of the future with cybersecurity implemented in it? Well, here's that vehicle. So the vehicle of the future with cybersecurity implemented in it can go around anywhere safely. It has protection mechanisms. It cannot be hacked, and that is where we have to take the connected, the autonomous vehicle, and that is where automotive cybersecurity is taking this new transformation in mobility. And when we come specifically to automotive cybersecurity, I would say that this is a new industry. A new industry is born. This is a blue ocean industry, and there was no automotive cybersecurity industry beforehand. I have been in automotive cybersecurity since in cybersecurity since 20 years, and I can tell you that cybersecurity SMEs cannot on day one understand automotive cybersecurity. You have to build that skill set, you have to understand the automotive requirements, and then move forward. But the one thing which automotive cybersecurity is focusing on is cyber innovation. It is a great example of cyber innovation. And in order to clarify that, I do want to give you the definition of innovation. So innovation is best defined as executing new and creative ideas that add value to the performance of the organization. Innovation is a combination of creativity, implementation, and a successful business outcome. So that is what is happening in the automotive sector as a whole. But when we talk about cyber innovation, so cybersecurity is an integral part of adding value to the business of the organization. But so right now, we don't look at the cybersecurity profile. And that is where we have to look at it from a cybersecurity innovation point of view. Again, a lot of things happening in automotive cybersecurity, a lot of innovation happening, and we need to address that the challenges. But when we address that challenges, there are opportunities in this sector. The connected and autonomous vehicle ecosystem, obviously, there are different components of it. And the three components where we have to look at it from a risk-based approach, we have to look at the automotive supply chain, we have to look at the in-vehicle security, and of course, we have to look at it from a V2X smart cities perspective. All of these together compose the connected and autonomous vehicle ecosystem. So I'll give you an example. A modern vehicle has 20,000 suppliers. So how do you secure that? How do you look at it from an in-vehicle perspective? What is the architecture of that? And when it is in a city, how does it communicate with intelligent transport systems? So the rest of all of that has to be looked at. And I do work with APMA, the Automotive Parts Manufacturing Association, and APMA and KPMG. They just recently issued the Canadian Automotive Cyber Preparedness Report, and this is a very interesting, has very interesting insights into the whole sector. When you look at it from a number of different perspectives, the first thing which comes across is many people still see cyber as an IT problem. So 42% talk about IT as that IT is cybersecurity. Others say 58% say that it is a business issue. So cybersecurity is a business issue, and we have to look at it from that perspective. Another thing which comes across is that many organizations do not have a strategy for cybersecurity. So when we look at the automotive industry as a whole, 16% have no strategy, 16% the strategy is in development, 36% yes within some areas, 32% yes across the entire organization. So there are obviously organizations which are in a leadership position who have a strategy, who are implementing it, but there are a significant percentage of organizations which need to look at what the cyber strategy as a whole. Another thing with regard to the digital crown jewels, 54% of the organizations that have identified their digital crown jewels feel they are protected to a considerable or greater extent. So 54% are protecting their crown jewels. And what is the crown jewels? It is your mission, your critical data, your processes, your services and systems that would cause major business disruption if compromised. But the question is, when we talk about automotive cybersecurity, do all organizations in automotive cybersecurity understand what are their crown jewels, number one, and number two, do they know how to protect that? So that's definitely a very important insight. Another insight which I do want to highlight, which is on the right side here, which says 49% of respondents indicate that their cybersecurity strategy leader is at the C-suite or equivalent. But 49% say they don't have any designated individual driving their cybersecurity strategy. So when we are saying that about half the companies out there don't have a cybersecurity leader in the organization, then that definitely shows that there needs to be a change in the mindset. Because if you are not looking at cybersecurity, then how are you actually addressing it? And then that is a huge business risk. Then we can look at the others also, but the one which is very important here is the top barriers to cyber preparedness on the left side: lacking the right talent, low visibility into the key risk, lack of support from leadership, unclear return of investment. So when we are saying that we have these significant barriers, and I know that during our panel we will discuss these, we do not have the correct talent. And as a cybersecurity person with 20 years of experience, I can tell you there's significant lack of talent in cybersecurity as a whole, but in automotive cybersecurity, there is really very limited resources, and there are very limited programs which are addressing that lack of talent. And as I said, you cannot just pick a cybersecurity person from, let's say, a financial institution and have them address automotive cybersecurity, because it's a totally different paradigm shift. Low visibility into the key risks. So we still don't understand the risk. So I'll give you an example here. If I am going from Toronto to Miami, and let's hope the pandemic ends soon and we are able to do that drive, and you're in a connected vehicle and your data is being shared in the different jurisdictions, what are the risks involved here? Who is getting that data? Where is that data being kept? And who is responsible for that data? And who owns that data? And who's responsible for securing that data? So those kind of risks are not even comprehended right now. And we have to do a lot of work in that area also. Lack of support from leadership. I did mention one key insight, which says 49% say they don't have any designated individual driving their strategy at all. So that is again another huge risk and needs to be addressed. I know that at APMA we have been really working hard to change that mindset and the culture where cybersecurity needs to be top of mind for all the industry leaders. And we've had significant success in that regard. And the last one, and this is always a challenge in cybersecurity, unclear return on investment. But as I said, automotive cybersecurity is all about cyber innovation. And when you look at cybersecurity from an innovation point of view, you do get a return on investment because it's a new innovation. Your business, it adds value to your business, and you can actually quantify that. So definitely, in this case, we can work towards enabling some kind of methodology on quantifying the return on investment. Now, there are other challenges which are, some are specific because of COVID-19. but those are something which have been addressed and which can be addressed further. The work from home environment, of course, has really had some significant challenges as far as cybersecurity is concerned. And the other thing is, were we prepared for cybersecurity, for work from home, and with regard to that, the cybersecurity challenges? So at the start of the pandemic, that was indeed a major issue, and that was also some of the findings in this survey. But one important thing which we did in this report is to define automotive cybersecurity. I know this is pretty small font, but what I wanted to mention here is, when we think about automotive cybersecurity, we should not just think about IT cybersecurity. Automotive cybersecurity is much more than IT cybersecurity. IT cybersecurity just looks at enterprise cybersecurity. So, if you're in an office environment, how to secure that. But then you have to look at the factory itself, the assembly plant itself, the manufacturing of the vehicle. So that is OT cybersecurity. So that's another area which you have to look at. Then the third area of automotive cybersecurity is the in-vehicle cybersecurity. So you can call that product cybersecurity maybe, because that is the actual components which are going inside your vehicle. Then the next one is supply chain cybersecurity. So you have to look at it from a supply chain perspective. You have to look at it from V2X cybersecurity. So how are you communicating with others? That's another area of cybersecurity. And then, of course, cloud cybersecurity, where is your data where is your data is present. So automotive cybersecurity is much bigger than just saying, okay, that our network is secure or it's all about IT. It is much more than automotive cybersecurity, and we need professionals and we need leaders who understand that and who implement these new technologies, tools, and processes in our environment. Now, if I go into a little bit with detail of each area of automotive cybersecurity, so vehicle security architecture, each vehicle is composed of, when we think about it from the electronics point of view, a number of ECUs, so electronic control units. Those electronic control units are basically systems which control a specific subsystem of the vehicle. So for example, here I'm showing steering and braking ECU. I'm showing airbag ECU. There is ADAS system ECU, lighting system ECU. So there would be a number of ECUs. And in a modern vehicle, these ECUs can go up to 100 ECUs. But let's say there are 50 ECUs in a vehicle. How are those ECUs compartmentalized? Well, how is, like, if I hack into the steering and brake, if I hack into, let's say, the airbag ECU, can I also go into the steering and braking ECU and then use that to stop the vehicle or accelerate the vehicle? So all those ECUs and other point of contact in the vehicle has to be designed, and that is where in-vehicle security architecture comes into place. You also have to look at access points to the vehicle. So here I've shown V2X over here. So that's an access point, Bluetooth, OBD2. What about your smartphone? How is that accessing that? So the keyless entry. So how are you actually enabling connectivity into the vehicle? And if there are more access points of the vehicle, then there are more places to secure. Now, one thing I like to highlight is, when we say cybersecurity, it does not mean that there would be, we would stop access to the vehicle. It means that we will have access securely into the vehicle. Then we have to look at secure vehicle software development. And as a cybersecurity professional, I can tell you that most apps, when they are developed, not only in the automotive side, everywhere, they don't have cybersecurity inbuilt into that. It's usually an afterthought. So, but what we have to do is do security by design and privacy by design. So starting from the concept to the software development, to the operations, and then finally to the disposal of the vehicle, we have to look at it from that perspective. So secure vehicle software design, millions of lines of code, So you have to look at it from that perspective. How do you actually secure that? We talked about a little bit about V2X, vehicle to everything communication. So in smart cities, how are you doing that communication? So vehicle to infrastructure, vehicle to grid, vehicle to cloud, vehicle to vehicle, vehicle to pedestrian, vehicle to device. So whenever a vehicle is talking to another vehicle or any other component outside the vehicle, is that secure? And there are methodologies of that. There are systems of that. For example, we have the Secure Credential Management System, SCMS, which can be implemented. Think about vehicles, 10 vehicles going in front of each other, and then one vehicle has to turn right, and it communicates to the other vehicle that I am turning right. How is that communication done, and is it done securely? Because otherwise, of course, we could have a lot of accidents on the roads. So vehicle to everything communication is an important part here. Fleet cyber incident response, a very interesting area. So one of the regulations out there which have come as WP29, UN EC WP29. So UN Europe Economic Commission for Europe. There's about 61 countries in that. And one of it, what it says is you should know when to detect a cyber incident in a vehicle. Cyber incidents in a vehicle should be detected. So fleet cyber incident response. So what happens when you actually detect a cyber incident? And so let's say just right now your vehicle is hacked. What do you do? And if it's a trucking company, if it's something like a regional transport, how do you actually respond to an incident? So that is an area where my company Vehiqilla is focused on, and I will talk about it a little bit more. But the fleet cyber incident response is a very critical area, and we need to look at it. Threats to the supply chain. As I mentioned, there are 20,000 suppliers in a modern vehicle. How do you look at that from a cyber perspective? So I'll give you an example. So there's an OEM, and it gets an entertainment system from a tier one, and there's a software being developed for that entertainment system by a tier two. And now we have to do a software patch update. How would that work out? What if we recently heard about the SolarWinds hack? If you haven't, just look it up. So the supplier was hacked to get into the to other companies. So how do you make sure that the whole supply chain is secure? And of course, you have to look at it from a digital manufacturing perspective, Industry 4.0 perspective. So your assembly plants, how are they secure? And cybersecurity, of course, is something which looks at it holistically. So if you're using Internet of Things or industrial Internet of Things, how does that apply? Similarly, if you're using 3D printing or big data analytics, how would all of that apply? So cybersecurity has to be looked at holistically when we look at it Industry 4.0. So what do we have to do? How do we have to improve this? We can improve this by establishing a holistic cyber governance strategy, securing the business through innovative cybersecurity. So as I said, it's all about cyber innovation. We have to look at it from a innovation perspective. It's all about securing and enabling the business. It's not about stopping the business. So you have to come up with your vision. So your vision should be business centric. It should be innovative. It should protect the organization data. And when I say the organization data, now if you think about automotive organizations, it could be an OEM, it could be a supplier, like a tier one or a tier two. It could be a fleet owner. It could be maybe dealers and distributors. So you have to look at it from a holistic perspective and protect customer data. So customer data in the vehicle becomes very important. If I am the driver of the vehicle and I have purchased the vehicle, how is my data being protected, and who owns that data and who secures that data? So that is becomes critical from this perspective. You have to have a capability roadmap. So you have to look at it from a business enablement perspective, technical controls, operational excellence, risk management, talent management. You have to look at your information system framework. So there are many information system frameworks which are applicable in the automotive sector. ISO 21434 is just coming out. It's in draft stage, but at any moment it will be published. I mentioned UN ECWP 29. Then we have TSEX out of Europe. Transport Canada had its own vehicle cybersecurity guidance, and a lot of great work is happening over there. And ENISA, the European Union Information Security Agency, has the best practices for CAFs also. So all of these frameworks can be applied to secure your organization and to secure your fleets. You have to look at it, the core investment. So maybe you need to do identity management, data protection, cloud first, automation, AI-based threat management, and device integrity. So all of those are important. And then you have to look at your operating objectives. So risk and compliance, user experience, resilience, financial accountability, secure hygiene, coverage, effective communication, and talent management. So you have to come up with a holistic cyber governance strategy, implement that. And the best part for automotive cybersecurity is that right now we can implement that from scratch, because this was definitely not something which was part of the automotive sector before. And we can build on other industries and utilize their insights to build this. Just a word about Vehiqilla. So Vehiqilla is looking at many different things. First of all, we have a program called Vehiassure, and Vehiassure is all about looking at the ECUs and looking at how secure they are, and then working with manufacturers to provide that information. So imagine if you're a vehicle and you have 50 ECUs and you want to look at the cyber risk of that vehicle. So you can look at the ECUs, are they secure? What is their cyber risk score? That is what Vehiassure program means. Then we have our own SOCs, the VHSOC. So VHSOC is where we are actually managing the connected vehicles through Vehiqilla. And then the next one is the VSOC program. And I find this very interesting. This is VSOC as a platform. So we can work with our partners to actually offer VSOC services. So for example, if you're a telco, if you're a government entity, if you are an entity which has a huge fleet or number of fleets for that matter, you want to manage them yourself. So we provide VSOC as a service to those entities. And the new one which we have just started, and I'm very excited about that, is the Vehi Protect range of products. So this is what will, so the others are more about monitoring, they're more about assessing the cyber risk, but Vehi Protect is all about securing the vehicle. And we have a number of activities under that. I do want to thank all the partners with whom we work in Windsor-Essex and across Ontario and Canada. Windsor-Essex Economic Development Corporation has definitely been a great support for us, lots of guidance, and they've always helped us, always worked with us to further our the Vehiqilla's efforts. APMA, of course, the Automotive Parts Manufacturing Association, has been and is one of the, I would say, leaders in automotive cybersecurity through their cybersecurity committee. And I'm very happy and proud to say that earlier I was the co-chair of that, and now Dr. Mitra is the co-chair of the APMA Cybersecurity Committee, and I'm sure lots of more great work will be done over there. We are also working with St. Clair College to develop curriculum and on research. Similarly, with the University of Windsor, OCI is, of course, and Evan is always a great help. And then I especially do want to call out the VR Cave. We are doing some exciting stuff at the VR Cave, and we will discuss that in our panel. We are making cybersecurity simulations, which is kind of a first. So we'll discuss that over there. That brings me to the end of my presentation. I do want to thank everyone for listening, and I hope you got some interesting information and knowledge through this presentation.
AJ, thank you very much for an amazing and detailed overview that you've presented. This is a great segue into the next portion and into the panel. So I'd like to take a moment just to acknowledge the panelists, the distinguished panelists that are going to be participating with AJ, of course, as a moderator. I'd like to start with Dr. Mitra Mirhassani. She is the Associate Professor in Electrical and Computer Engineering at the University of Windsor. Welcome. Mr. Bob Gordon, Executive Director of the Canadian Cyber Threat Exchange. Welcome. And Mr. Peter Elliott, who is the Global Information Security Officer at Magna. Welcome as well. And I have the privilege of also joining in and kind of giving a little bit of a perspective from the Windsor-Essex region. So I'll now turn it back to AJ to start the panel discussion.
Thanks, Ed. I think before we go into some questions, maybe we can have a more detailed introduction. So Robert, maybe you can start. Do tell us about yourself.
Yes, good afternoon. Thanks, AJ. I'm the Executive Director of the Canadian Cyber Threat Exchange. We're a not-for-profit organization that was set up by the private sector to provide an opportunity for companies to get together to share best practices, ideas, learn from one another, and also to exchange information relating to cyber threats. So the kinds of things we're talking about today is exactly what we're in business to do.
And Dr. Mitra?
Thank you. So I'm from the University of Windsor. I'm from the Electrical and Computer Engineering Department. And these days we are busy trying to solve some of the challenges regarding the hardware security, the parts that are manufactured and will be used in vehicles of future, which is a very, very challenging area. Thank you.
That's a very interesting area, and we'll definitely discuss that more. Peter, can you tell us a bit more about yourself?
Sure. Hello, everyone. Peter Elliott. So I'm a 19-year veteran at Magna. I've worked in multiple technical roles and now essentially lead our information security risk and compliance group. AJ mentioned in his presentation there about the 4 distinct areas. So I really worry about the IT side security, operational technology, and third-party supply chain risk. So these are the key areas that I'm responsible for managing risks within Magna.
Thanks, Peter. I'm sure we'll have lots of great insights in those areas in this discussion. But I do want to begin with Robert because he's got a wealth of industry experience and he has a very holistic perspective. Robert, one of the things which I mentioned in the APMA KPMG survey was that we have seen a lot of breaches, and even in the automotive sector. With one insight was that 30% of respondents experienced a breach in the last 12 months. So what would these breaches look like, and how would an organization respond to something like this?
Thanks, AJ, and thanks actually for your presentation. Some really interesting insights of what the future is going to be, but also some really sobering comments in your overview, and the percentage you just talked about on the number of companies that are being hit. I think they actually underestimate what's going on. There's been some studies that came out at the end of last year that actually looked at about 38% of companies don't even know they've been subject to a breach. So you've got 30% are being hit and 38% don't even know. So that's a big percentage of companies that are actually going on. So what I'll do is just talk a little bit about a couple of the most common kinds of attacks that our companies are seeing. And both of these particular types of attacks revolve around some way of actually stealing your money, broadly defined. And the first is what we call ransomware. And that's where attackers want to do something to basically force you to pay them a ransom. And there's a variety of things that they can do out of that. And the second is what we're calling business email compromise. And that's a scam where what the criminals will do is come in and spoof a legitimate email address. They're going to come back and exchange some information or a correspondence with one of your employees, all of which is trying to get one of your employees to send the attacker some money. So let me give you a little bit of a little more insight into what's actually happening in those, because the trends are changing and they're changing quite rapidly. So when we first saw ransomware attacks occurring, what the attacker would do is come into your network, they get inside it, then they would encrypt your data, basically making it's unusable. the first thing you become aware of it is one of your employees would probably come in and say, wow, I've got a screen coming up that says I've actually been attacked by ransomware and I can't do anything with my system. The only thing you can do at that point is there'll be a screen that comes up from the attacker saying, here's, being very helpful, here's how you can send me your money, usually by doing some kind of a digital currency. And that had been going on for a little while. But what the attackers are now trying to do is how are they going to increase the pressure on you to make that payment? So one of the things that they've started to do is not only will they encrypt your data, they're actually going to take some of that data, they'll post it on an organized crime website for ransom or for up for sale, and they come back and tell you, hey, look, we've already taken all your data out of there, you can't use it. And if you don't make this payment pretty soon, A, the cost is going to go up. And second, we're going to start to release more and more of your data up onto organized crime websites for sale, all of which trying to push it on it. They've started a new one now where what they're doing is going through and saying, not only are we going to encrypt some of your data, we're going to start doing denial of service attacks. So the thing that used to come in and they'd say, and you would deal with that, and we would all we've been dealing with that for years. But now what they're doing is they're doing it as a ransom and saying, before we actually do it, we're going to tell you we're going to do it to you. Pay us a ransom, then we won't do a denial of service. It's kind of a cheeky way of actually getting back and increasing it. We've seen some recent twists in the past, and I'm saying recent in the last 10 days, that the attackers are actually doing. So in one instance, we had a company come along, we actually contacted them, and we said the company decided they weren't going to pay the ransom. They didn't think that what they was taking was valuable enough. So what the attacker did is the attacker approached the news media and said, company A's data has been stolen because it got lousy security on there. The news media phones the company and says, now what are you going to do about it? And the company, because the pressure starts to mount, the company comes along and says, okay, yeah, we're gonna have to pay, or our reputation is really going to go down. In another instance, we contacted a company through our organization end of last week and said, did you know that your information is actually up for sale on a Russian organized crime website? They had no idea. What had happened, and they subsequently back and checked, the attacker had sent an email into their system saying, you've been subject to attack. If you don't pay it by X date, we're going to start releasing more of it. The company actually had deleted the ransomware note, thinking it was a spam email coming in. And fortunately, we were able to tell them, so they were able to go away and do it. And then we had another attack that occurred, and it actually occurred over this past weekend, where a Canadian multinational manufacturer of IoT devices, they got hit with a ransomware attack. And in that instance, and it goes back to something both AJ and Peter alluded to, it's the attack came in on the IT side of the organization, but the effect was on the operational side. It basically shut down the manufacturing plant's capability to operate. I don't know whether they've paid or not, because this is an ongoing attack. And I mentioned this, the second type are the business email compromise. And what's been happening there is attackers will get inside your network. They'll spend a fair bit of time understanding what's everybody's roles and responsibilities. What are some of the major initiatives you got underway? They'll then, for example, and I was recently dealing with a company where they found out that the president was going to be traveling. They then send a spoofed email pretending to be the president to the employee that should be able to make some changes to some billing information, and away the money went. They said, okay, please, instead of paying the money into this account, please put the money into the other account, which happens to be the attacker's account. The money was gone. And the problem with those attacks is if you don't become aware of it right away, your chance of getting the money back is pretty slim. And the other thing this small company did, and we were talking, AJ, you were talking about the number of suppliers. This is a small manufacturing company. They got hit for a $95,000 US ransom. They can't afford that. They thought their cyber insurance would cover it. But because this was a conscious decision of one of their employees to send the money out, the insurance doesn't cover it. So some interesting things you may want to be thinking about when you're starting to look at your cyber insurance is, what's actually covered and what's not. So what happens when an organization gets hit? The first thing that's going to happen is everybody's going to go into a panic mode. There's going to be that momentary gasp where you start holding your breath and you're starting to think, oh no, this can't be me. This can't actually be happening. And that's where having a business continuity plan actually kicks into gear, and where you've done the exercising, because you then know what are the roles and responsibilities of who has to get involved. And it's, as AJ, as you said, this is a broader issue than just the IT department. When you get hit with a cyber attack, this is an all of company undertaking. This is certainly going to be the IT group, but it's going to be the business group that's going to have to be sitting and trying to decide, what's the impact on business operation. It's certainly going to start to involve your lawyers and breach coaches, insurance companies, your communications group, both internal and external, are going to be having to deal with it. You may have to, depending on your circumstances, you may have to be thinking about advising your people like your regulators that are looking after you. Are you going to contact law enforcement? And more importantly, are you going to have to, what are the parameters under which you've got to tell the board of directors? And you want to sort all of that out long before the attack occurs. When the attack occurs, it's too late to be sitting back and trying to sort that out. And that will let you get back into that breathing mode. Your processes kick into place, and you'll be able to take it from there. Back to you.
I think that's very illuminating. A lot of challenges there. So, Peter, how would an automotive organization handle such cybersecurity incidents? And where you're positioned, you mentioned you also deal with the supply chain. So, an OEM or a large tier one, how would they handle this with their supply chain also?
Yeah, so being from a large tier one, I mean, I'm sure the other automotive supplier participants that are here can appreciate that. I mean, it's all about taking a pragmatic, risk-based approach to these things. One of the things that really, and obviously putting it in business terms for management so that you can get the support. I mean, the APMA KPMG survey really resonates with me in this disconnect where you've got a lot of people that still think that cybersecurity is an IT problem. It is 100% a business problem. And the risk organization, frankly, isn't doing their job if they're not able to communicate that risk to management, because I think that's where there's often a big disconnect. One of the things at Magna that really helped us drive this message home within the ranks of our organization is several years ago when we went through the exercise of acquiring cyber insurance. So, this really helped us, look at what our risks are, quantify them, and then, most importantly for the top levels of the organization, start putting dollar amounts on these risks and, really understanding, and what is what they call a material incident. So what is material to the company in terms of some of these risks? And then you can really have very frank discussions about where you're going to spend the money, formulating your program and spending money in the right places, because you really want to get your biggest bang for your buck when it comes to mitigating some of these controls, and that's something that you can easily explain to within your organization. So it's all about residual risk, right? Looking at what the inherent risk is in a particular area, what mitigating controls that you have in place, and there you're left with your residual risk, and thinking about it and talking about it in dollar terms with your management. So I think that's really important. Rob or Bob already mentioned that having these sort of business side investigations that are done, or doing a business impact analysis, doing proper business continuity planning, and having that disaster recovery plan. I mean, in terms of preparing for an incident, I mean, those you just have to have in place, right? Especially if you think about the whole automotive supply aspects, right? So what is the impact if you're not able to get certain materials from the supply chain side? Do you have other sources you can get them? Manual processes if you're electronic systems like whatever your enterprise resource management, your manufacturing execution systems. So what's the impact of these systems going down? Layered defense. At Magna, we're a big fan of the NIST model, because it makes perfect sense for not only cybersecurity professionals in IT, but this, the whole breaking things down into identify, protect, detect, respond, recover. It's digestible, even for executive management who don't do this as their daily business, right? So, and I think a lot of people here are going to be familiar with those concepts. So, I mean, first step, knowing knowing your assets, what assets you have out there, whether it's in the IT side and the operational technology area, knowing your assets and what you've got out there, and knowing ultimately what your crown jewels are is absolutely key, right? So that comes back to money well spent on cybersecurity. If you don't know those things, chances are you're going to be spending money in the wrong place, and you're not going to get a good, security return or risk mitigation on that investment. The protect. So, these are just your, often case, just your general controls that you're putting in place around access, around, around things like endpoint detection and response capabilities, these kinds of things. You need to have that central visibility. And this is something that we've struggled with. We're in 29 countries, 350 manufacturing plants around the world. So your ability to detect something happening really depends on your ability to ingest large amounts of data and to be able to identify things quickly when they're happening. I mean, at this point in time, if you're thinking that you're just lucky that you haven't been hit yet, I mean, very unlikely. We all have to expect that we are going to get hit eventually. And then it's really, how quick can you identify that? Do you have systems in place to identify it? How quickly can you respond and ultimately recover from those types of things? So, already mentioned before, I mean, all these things have to be in place before the incident happens so that, you're not freaking out, for lack of a better term, and don't know where to turn, right? These things need to be already in place before the incident happens. And it's just a question of if, not when, right? Now, needless to say, I mean, even at Magna, I can say this is a continuous improvement exercise for everybody, right? Nobody's perfect. Nobody's 100% secure. There are challenges. You really have to try and stay, as realistically ahead of the threat actors as you can. Some of the challenges that we face, and I think is just a general automotive supply chain issue. So the level of engagement between OEMs, tier ones, tier twos, tier threes, all the way through really is a challenge, right? I actually just recently participated in a tabletop exercise, the first I know of, with one of our large OEMs, actually several OEMs. So this is a first. These things are starting to happen. One of the main sort of outcomes of that was, how do we communicate with each other? Because we've all got our own company's reputations to protect. Obviously there's the legal aspects of disclosing information, the potential, legal and reputational ramifications of that. But at the same time, it's very difficult to protect the supply chain if we're not talking to each other and communicating risks in real time. So there is work happening there, and that's really, a good thing to see happening. But the industry has a long way to go, I can tell you. I mean, it's still to this day, when an incident happens, most companies are frankly trying to sweep it under the rug. This is why ransom payments, I think approximately half of companies that get ransomware end up paying. They want to minimize this and not frankly be embarrassed or have their reputation damaged by it. And I think that needs to change, right? We need to stop feeling like victims. So I see improvements there, but yeah, it's really a challenge. I mean, the scale that we're talking about. I mean, Magna alone, we've got 18,000 direct and indirect suppliers, just to give you an idea of scale. Right. Our largest customer, GM, I think it's on the order of 35,000. It is just a massive landscape. Inroads are being made, but I think one of the other challenges that we face is sort of the traditional, what I would call the traditional or legacy view of supply chain risk. It's more focused on viability of your supplier and how are they doing financially? Are they going to be here in 6 months? If they aren't able to supply me the part, do I have another supplier that I can go to? Like, the traditional supply chain risk is really about, more of the logistics and the supply side. And what we really need to do is do a better job of educating people that the cybersecurity aspect of the risk is just important, because it doesn't matter to me if I've got a supplier I'm dependent on. whether it is a, whatever, an issue on their side, a machine goes down, or they don't have the raw material, or they get ransomwared and can't deliver because the machines aren't operating due to a ransomware attack. Doesn't matter. At the end of the day, we can't build a finished product, we can't deliver to our OEM, and you literally have assembly plants with 15,000 employees plus sitting there twiddling their thumbs because they can't get a bumper from Magna, right? So these are the things that we really as an industry need to focus on and improve on. So seeing positive change there, but we still have a ways to go. As I said, continuous improvement.
Thanks, Peter. Yes, definitely. There are a lot of things to do. And one thing from your comments, I feel is we need a lot of skilled industry professionals, and at the moment that is lacking. So, Dr. Mitra, I know that University of Windsor has started SHIELD, which is a center of excellence in this area. How do you see this lack of awareness and education and how do you plan to fulfill that lack of skilled resources?
Yeah, so this is actually very, very critical. I say that lack of talent, basically not being able to retain even the talent that we train in our universities is one of our biggest challenges that I see that the Canadian cybersecurity atmosphere and ecosystem faces. We, for example, train our students specifically about the area of auto security, and we see them go down south the border and they're just get employed there very easily. So we don't actually have, I don't see them motivated to stay within Canada. That, and also most of the educational programs are either, for example, from the IT security, they are trying to tailor it somehow to automotive security, seem to be rather very expensive, unaccessible to a lot of the interested people or young talent. Some of those certificates are costing north of 10K for one certificate program. That's not very easy for anyone to have if they want to have multiple of them. And the other problem is that even when they get that they are not dedicated to auto security, they are for IT security. A lot of the programs and educational curriculums that we take a look at, in order to rush into the ecosystem, these centers, they just basically use the plug and play. So they have a couple of courses here, a couple of trainings here, they just package them and voila, we have a auto cybersecurity education. And when you get into the detail, you see that that's not what I mean, there are some similarities. There are some basic principles of security that is applicable to IT and auto security, but they're not actually designed having that holistic approach, holistic look at auto security. So there is not a lot that we have currently in Canada, and that's what motivated us. That along with a lot of the initiatives that are taking place in the Windsor-Essex region, we also established the first Automotive Cybersecurity Center of Excellence, which is one of its first kinds at the University of Windsor. And what we're doing, we are inviting industrial advisors on board. We're learning from what type of skills they really need, not just to sell certificates, but to actually look at what is required in industry. We would like to also have an agile and very basically fast moving, active, dynamic curriculum. Usually most of the degree programs, they take years to establish, and then they're very slow to answer the trainees. So trainees get their degrees and then they have to go and get additional trainings to be ready to go to industry. So we would be able to, on this basis, we would be able to design, update, and move with the river, with the flood of the information in the cybersecurity, update our curriculum and provide information that is usable for the students, not just some theoretical things that we as professors think are required to have. So this approach, having the industrial advisors on the board, has helped us to basically start developing the curriculums, and hopefully we will be rolling out the classes. And we are also trying to reduce the cost by all means. We would like to remove the barrier for education and training in the field for everyone. We're not trying to make a lot well, we have to pay the instructors, but we are trying to basically use volunteers mostly, so we don't have to pay or put the cost of education on the back of the trainees, rather try to use some of the university resources. And I have to say, University of Windsor has been very supportive of this initiative. So we are very, very optimistic that we can create dynamic, dedicated courses for auto cybersecurity at good prices that we can offer with general public, and hopefully basically create that mentality, create that discipline that's not just connecting a couple of cybersecurity courses together will enable you to train the talent in this ecosystem, but you actually have to look at the whole automotive cybersecurity, namely hardware security has never been, or it's still one of the very side parts, smaller voices in the auto cybersecurity. But we are coming to realization that you cannot have auto security without having a secure hardware. So we are trying to bring that perspective also to our courses that are designed. So yeah, I think I say in a short answer, lack of talent and resources. The common problem everywhere.
Yeah, well, sounds like a lot of interesting stuff is happening at Shield, and lots of good work is being done over there. Ed, I want to come to you because Vehiqilla is doing some work with you on the virtual reality simulation in the VR cave. Can you give us some details about that, and how would it further our understanding of the impact of cybersecurity breaches?
Yeah, for sure. Thanks, AJ. You know, from my perspective, not being in directly in the cybersecurity space, you know, creating awareness around cybersecurity is absolutely critical from anyone's perspective. You know, demonstrating threats in an interactive simulated environment can certainly allow a person to understand what can happen during a potential attack, and that's where the VR cave can shine. So, you know, the VR cave is the environment that we have, is probably one of the only ones that are out there that's available for public testing. And using cybersecurity scenarios is quite new. And when we can do this is something obviously we're working on with your company, and we're very excited. So one thing that comes to mind is when you're training a driver for a threatening scenario or a situation, using virtual reality can certainly help to identify how a person may react to a situation. You know, for example, you mentioned it in your presentation, you know, a car is hacked through connected infrastructure, an ECU, and the vehicle is then made to accelerate unintentionally. So under normal circumstances, you know, the driver might panic and they might actually apply the brakes very hard and potentially cause a chain reaction or an accident. And so when you think about a cybersecurity detection system, obviously in something that you're working on with the software, an intervention that takes place that would help a driver realize what it would take to bring them back to normal operation or safely move them to the side of the road is something that we can test in the VR cave environment. And so, you know, these are things that are unique. So it's really situational type of testing that we can do together. And also the software, of course, that you're using is how does our system communicate with the software that you have to be able to provide feedback and obviously have different scenarios where you can interject and cause the vehicle to react the way that you want it to. So I think I'm most excited, AJ, to be able to show the public and others what we've developed together. I know we're still pretty much at the beginning stages, but we're working pretty diligently on it. And when we're able to share more, I think that people will really get to appreciate it and maybe even experience it in the VR cave themselves.
Yeah, and I definitely am very excited about that. And this is one of the things which I feel Windsor-Essex provides Vehiqilla, the opportunity to work with entities like yourself at the VR cave and develop these cybersecurity simulations, which I don't think anyone else in the world are doing at the moment, or if they're doing, it's not known. So we're very excited about that, and we'll definitely have a great demonstration once that is completed. Dr. Mitra, I do want to come back to the hardware security, because as you mentioned, that is something which is not mentioned, but it is of course critical. We all think about the software side more. So can you just elaborate on that, and how does that impact a connected vehicle?
Sure. So hardware is actually never looked at, and I have to say, well, I'm exaggerating when I say never, but we are not appreciating all the attack points that it will or might add to a vehicle or any IoT system. Well, there are different ways of that the hardware is basically can be revealing your information. The very most well-known approach is the side channel information, right? So if you're running an encryption on an FPGA, even though your FPGA is having all the other sorts of computation, but it also runs on the side an encryption algorithm, you can pretty much isolate that encryption, and theoretically and through a software hacking, that encryption algorithm needs years to be broken. In hardware, through the side channel information, you need a maximum of about an hour. Not a lot of information about the mathematics or the number theory or all the complexities. And it's rather inexpensive to be used. A mid-range oscilloscope and a couple of, an Excel or MATLAB software, which are mid-range. And there you go. You have the code, the secret keys that your encryption is relying on. And it gets basically critical because your car, you cannot always carry it in your pocket. So you leave it on the parking spot, you leave it in repair shop, you leave it in the chargers, unknown chargers, and go to the hopefully mall when they open, or shopping centers, or wherever. You go to camping trips. So you don't always have a very view of your car. But also you sometimes take it to repair, changing the oil, repair shops or so on. So those are the times that your vehicle is pretty much accessible with your permission to whoever is in that shop. That's one side of it. The other side is actually the parts that go to the vehicle. They can be suffering from several types of attacks. For example, the most well-known one is the Trojan hardware. So you receive these parts from the manufacturing, where they are manufactured, and you basically assemble them to form the whole vehicle, either in form of an ECU to a certain sensor. Would it be, for example, the adaptive sensor, tire pressure monitor sensor, as simple as that, all the way to, for example, more complex electronics within your car. There is a lot of difficulties in figuring out if the parts that you ordered is actually exactly has all the parts or the functionalities that you wanted it. Because now we are realizing that, and I'm talking about the nanometer dimensions. So within those IC packages, a difference of 5 or 10 nanometer in one of the wires intentionally inserted there, insertion of very tiny, even one capacitor within the millions of transistors on that hardware, as well as nowadays we are realizing even changing the balance of the chemistry that the foundry, the manufacturing in the very early stage of the device manufacturing has, is using, can result in a form or some sort of Trojan hardware. And those are non-visual ones. I mean, I've seen people when they try to detect the Trojan hardware, they say that, okay, we pick a couple of samples, we remove layer by layer material, we go over and we detect and see if all the wiring within the nanometer dimensions, again, within inside your hardware, is everything okay? But I have to say, the new Trojans are not even visual through those microscopic and X-ray methodologies. So what they can do, they basically can get activated either randomly through certain times. They cause, for example, certain charge or certain abnormal activity to happen within one microscopic place of your IC. And that would be basically their trigger. And then they have a payload, and the payload depends on the designer, what they want to get out of this. So the payload depends all the way from erasing all of your data, erasing all the functions and values from your FPGA, which basically, if you're thinking about an automotive autonomous vehicle, means that one part is just all of a sudden doesn't have any value or any functionalities, all the way to even having access to the infrastructure. So you are connecting the car, and the power providers are allowing you to access, to connect your car to the chargers. And there are these worms that start, the payload of the Trojan can be a worm that travels through your network this way. So the hardware security, and we're just discovering this. So I used to be an engineer that was just designing mostly the quality control, custom design quality controls for a lot of car manufacturers and industries in Windsor-Essex. And all of a sudden I realized, oh my God, there are so many information that are being overlooked. So that Trojan hardware by itself adds a lot of complexity to the integrity of the supply chain. Who's manufacturing my parts? Where does it come from? And those parts are not, the productions are not fully vertical lines. They travel back and forth. You receive most of the design blocks from different entities. You put them together and you get that one block of IC by itself. So even for that small devices, at that small dimension, there are so many unanswered questions that we are facing. All the way that, for example, I see now that even in Amazon, you can go and buy deep learning on a USB stick, right? So easily that USB stick can carry with itself either a Trojan hardware or software of your AI. We are relying more and more on this pre-built, accessible, buy it from Amazon parts and just plug and play and go. With it brings a shift in culture. People want to pay less and get most out of their cybersecurity solutions. And unfortunately, hardware security adds to the cost. It is one of the things that means that you have to think very smartly from the early inception of your smallest components, even that were going to be used in the car, all the way to after you get rid of your car. What happens to your data, the residual data that remains on the hardware, even though you did a factory reset? What happens to that? So the hardware brings a large overall span. It adds a lot of complexity, unfortunately, and it adds the cost. And that's the puzzle that we have to come and basically collectively try and solve it. Because the auto manufacturing is a very lean process. There is no way to add more money or more cost. We have to basically justify even addition of half a cent or a percentage of a cent to the production. And addition of additional hardware security is definitely more than a couple of cents for each of the components. So I think that we have to give this part a little bit of thought and come up with a solution. Maybe we create subsidies, I don't know, get a help from governments, maybe larger OEMs can assist, but it's certainly starts to show its impact. The lack of security in hardware starts to show its impact more and more these days, as people are getting more basically, or getting smarter, getting more knowledgeable about the aspect of how to attack a car. It's kind of like a sports these days. Try to hack a car. It seems like a lot of young students and talent want to do that. Which is good. We need to basically look at it, but it all means that we are getting the information is out there. Now we have to put our minds together collectively, academia, industry, non-for-profit, and government organizations, and see how we can come up with a good solution. Yeah.
Yeah, it seems like a very important area, and seems like we will, if we don't address it, there would be many breaches on that side, and we definitely have to look at that. So, Robert, I do want to come to you, and we've been talking about cyber breaches and various events. So, what should companies look at from a legal perspective, and how can they best safeguard themselves from such incidents?
Yeah, the legal perspective is a big part, and it's becoming a very busy environment. We're starting to see an evolution in the laws and regulations that are going to have a definite impact on automotive cybersecurity. I think part of it is we're starting to see three trends coming together. The first is laws and regulations are starting to catch up to technology and how we use it. And the second is our understanding as a society of what's acceptable use of data and privacy is starting to evolve. And then both of those are now being informed by the consequences of the cyber attacks that are hitting us. So let me give you a couple of concrete examples. If we look at Canada, our whole legal framework on privacy is really starting to be updated. So you remember that last November, the government introduced a new, they call it Bill C-11, and what they're going to do is create out of that a Consumer Protection Act. And that's going to really update Canadian privacy legislation, and it's going to bring us more in line with what a lot of the international standards. So if you're familiar with what's called GDPR in the European Union, a lot of those same provisions are now going to apply in Canada. And it's going to affect the private sector because basically it's going to spell out in more detail what controls are going to be placed on the use of personal information that's held by businesses. So it's going to have a direct impact back into the automotive sector. Let me give a couple of specific examples. So when you think of the privacy commissioner in Canada, one of the things the commissioner's complained about is he hasn't had the authority to actually go through and make orders on what companies have to do. That's going to change. The privacy commissioner will now be able to come through and order a company to actually undertake some activity that he thinks is appropriate to further protect information. And if you want to think about trying to ignore that, what they're doing is now they will be providing some fairly stiff penalties if you don't follow the regulations. And it's going to be some of the toughest penalties in the whole G7 group of companies, or countries rather. In the one instance, it could be $25 million or 5% of your annual gross revenue, whichever is bigger. So these are going to be some serious fines that are going to start to be imposed on that. The other thing they're going to do is some of the things that were generally considered as principles or best practices under the previous legislation are now actually going to be put into place. And one of those, for example, is they're now going to force an organization to have privacy management programs. So every company that's part of the automotive sector is now going to have to formally put in place some of these programs. And failure to do that, again, going back to what I was saying before, the privacy commissioner can now come through, so if there's an incident, and actually force you to go through and do some of that. And there's going to be some changes making it stiffer on, getting consent to use people's information and what that actually entails. And that really becomes interesting because one of the things that's come out, particularly in Europe, is in Europe, they've decided that a vehicle identification number for the VIN, for example, is what for VIN, is now being considered to be personal information. So what the experts are starting to say is any data that's gathered or generated by a vehicle and it's associated back to the VIN, all that information is now going to be considered personal information. So all these new provisions that are coming out in law are now going to have a direct impact when you're starting to look at sort of what's going on in the whole automotive sector. Provinces across Canada are also starting to make similar kinds of changes. When you start looking at both Quebec and Ontario and British Columbia, more notices are going to be required when there's a breach occurring, what you're going to have to do. So again, a direct impact back on what's going on in Canada and affecting back onto the automotive sector. It's tough to tell how all of these laws will, because the laws are all under development, they're all being considered. So it's tough to predict sort of what they'll look like in 6 months, but I guarantee it's not going to be less restrictive than what it is currently. So there's going to be more of it. And we're starting to see changes in the United States. Again, they're going to have an impact back in the automotive sector. So in California, again, in November was a busy month. They've taken to expanding their Consumer Privacy Act. They're expanding the definitions of what's considered in there. And they've now included a category, what they're calling sensitive data. And there's a whole list of things that are on there, but it's going to include things like contracts are going to be considered part of that. And it's also going to apply down to service providers are now going to be captured in that. And what's going to be caught are things like login credentials and geolocation information. So if you've got a vehicle that's doing geolocation, which is an autonomous vehicle, you're now going to be caught up by and you wouldn't know to think about it, the Consumer Privacy Act of California is not going to have a direct implication on sort of what you're doing on that. In Europe, they're expanding out the powers. One of the problems with GDPR, it was tough for them to enforce that between countries. The enforcement regimes weren't there. They're changing all that. They're now going to bring a whole new regime to allow it, make it easier for the cross-border prosecution and protection of cases. So they're stiffening up some of the ways that they're going to have to be able to actually come back after those who haven't been following the regulations. AJ, you mentioned in your presentation, some of the regulatory, so that's on the legal framework, and there's lots of laws coming out through that. But there's also changes occurring in the whole regulatory framework that has a big impact. AJ, you mentioned some of them. The ISO 21434 is coming through, and it's going to cover the entire life cycle of vehicles, basically putting a whole cybersecurity management process into place on all those things. It's going to require the implementation of planning to be able to track cyber activities, and actually forcing all companies to get into a threat risk and an analysis framework. So you're going to have to start becoming much more regular regime you're going to have to put in place in that whole life cycle management of it. You mentioned the United Nations on the WP29. Again, unprecedented vehicle cybersecurity regulations that are going to be coming into effect. It's going to affect certainly any part manufacturer that's supplying into Europe is going to be hit up by that. Transport Canada is getting into the act with their vehicle cybersecurity guidance that's coming through, and it's going to focus on privacy and, again, data protection. And I think you have to start thinking of cars, automobiles, the whole automotive sector as just being a computer that's driving down the road. So a lot of the things that you used to think about just relating to the IT, your corporate IT, are now actually going to be extending out to the car. So a lot of things that Peter was talking about having to do looking at the corporate side are now going to be just as relevant when you start looking at that car going down the road. It's just another computer. All the regulations that are going to affect on the IT side are now going to start to fit into the car. Okay, so before you throw your hands up and say, okay, now what are we going to do? The world's falling apart. There are some things you want to be starting to do. One is, and it's fairly simple, is actually start to build a map of where is your business and where does your data reside? Because that will start to give you an idea of what are the places or the kinds of regulations that are going to impact on you. And then once you've got that geographic map done, then start to prioritize the regions. What are the areas where it's going to be most problematic, where the regulations are coming out are going to have the most impact? Then you can start to identify some common baselines, because there are some common threads that are going to fit between all of these various regimes. So maybe dealing with what you do in regime A will set you up nicely for what's going on in the other country. And then the bottom line is you're going to have to stay up on these legal frameworks that are coming up from around the world. There's going to be no way around it, because they are definitely all going to come back and hit in some way into the entire automotive sector as you move into the autonomous vehicle field.
Thanks, Robert. That was very detailed and lots of insights over there. I do want to highlight WP29 again, UNEC WP29, because that is being implemented from 2022. Actually, it was 2021, but in 2022, some countries are implementing that. And any vehicle being imported into Europe or South Korea or Japan would have to follow that. Similarly, ISO 21434, it is at a draft stage right now, but it is going to be published anytime. And what ISO 21434 does is it lays down a great framework to implement in your organization as far as cybersecurity is concerned. It looks at the concept phase, the software development phase, the operations phase, and the disposal phase. And it looks at continuous activities. It also looks at supply chain. How do you deal with and how do you have a supply chain agreement? It all, as Robert mentioned, it also looks at and it focuses on threat and risk assessment in a big way. It talks about cyber monitoring. It talks about the need for enabling the management commitment. So how is management actually enabling the whole cyber security framework? So a very detailed document, and at APMA we have developed a cybersecurity an ISO 21434 self-assessment questionnaire, which is available from APMA for our CyberKit 2.0. And we've also developed a hardware security module in CyberKit 2.0. So there are a few good things over there. A V2X module is there, and an OT module is also there. So, and on OT, Peter, I do want to come back to you because again, this is a very important area, but not often talked about in cybersecurity perspective. So with the advent of smart factory technologies, how does that impact the overall cyber risk posture of the organization? And what should we do about it?
Okay, thanks, AJ. So I guess the answer to the first question is easy. It has drastically increased the attack surface. There's no doubt about that. I mean, there was a day where sort of the approach to OT security was to implement a so-called air gap network, right? So either physically or logically separate your OT environment from the rest of your environment, knowing that things like patch cadence and uptime requirements there are well, fundamentally different from the IT side. I mean, I think everybody by now should know, but if you don't, I mean, the air gap is effectively dead. If you think you've got an air gapped OT network right now in 2021, I think if you look a little closer, you'll find that it's full of holes. And I think this largely started with, I mean, obviously, everyone knows that there's all these marketing terms. So whether you want to call it smart factory, industry 4.0, factory digitization, digital factory, I mean, it all comes down to the fact that there are more and more connected devices, sensors, so-called industrial Internet of Things devices in the production environment. I think, probably one of the most well-known or early use cases was, in sort of the predictive failure analysis area. Obviously, keeping machines running is, tantamount to money rolling in the door, right? Especially in the parts supply industry, keep that machine running, pump out parts, get them to the OEM, on time and the right quality. So predictive failure and analytics was a big one, right? Knowing when machines are going to fail before they fail. And it's all about, this whole space is all about uptime. But it's gone a step further now, right? Or several steps further, I guess. Now it's all about process optimization. How can you, squeeze more out of your OT environment? How do you get that, that better weld every time or whatever the case may be, and actually improving the process, right? Again, all around uptime and all of these things, they're just generating incredible amounts of data. I mean, we're kind of used to dealing with the data problem sort of on the IT side. It's newer on the OT side. We're just generating incredible amounts of data there. And this has really led to, somewhat of a convergence in the IT and OT spaces. And there are real implications for that. So the first part of your question, absolutely, it's increased the attack surface. what we should be doing about it is a bit more complicated. So I'm going to sound like a broken record here. I mean, to start off, again, it's educating the organization on the risks. Similar to what I said around supply chain risk and sort of the legacy views held around that, I see this in the OT space, right, where you know, it's very focused on uptime. You know, things that we kind of take for granted in the IT space. I mean, people are used to whatever, Microsoft Patch Tuesday, right? The second Tuesday of every week, everyone knows they have to patch and reboot their machines. That's not the case in the OT environment, right? So for a couple of reasons, again, it's uptime. You can't be patching, you know, monthly, or in some cases not even quarterly or biannual. I mean, often we have some 24/7, 365 plants where maybe you've got a summer and a winter shutdown. Maybe it's only once per year, right? It all depends. So your patch cadence there is totally different, and therefore your risk posture is different. So, you know, again, educating executive management on the fact that you know, as I mentioned on the risk-based side. So if you have a cyber incident in your OT environment, that goes right to downtime, right? I mean, that's one thing that needs to be understood. So partnering with the OT people, and this is one of the things, you know, on our journey that we've learned. I mean, things tend to be pretty IT centric, depending on which facility you go into. Maybe you've got an OT competency, an OT team. In other cases, maybe it's really maintenance people that are responsible for the production environment, and they're not even really can be considered OT people. And in other cases, still, maybe it's kind of a shared responsibility. Maybe you've got a completely outsourced a line where, I mean, literally, you've got a third-party company that manages it, and you know, you've got local staff that essentially call the 800 number when you know, when something goes wrong. So from facility to facility, there really are differences there. I mean, you know, if I look at our company, you know, we have one line of business that does, you know, contract vehicle assembly. So we're essentially an automaker in one of our lines of business. So obviously in that space, much more mature, largely driven by the OEMs, not really, you know, the biggest risk that we have. But, you know, we're a large, diverse company. We've got other plants where they're, you know, let's say stamping out a specific injection molded part. They don't really see cyber as an issue from them. There may not be, you know, maybe the sensor is added to that part further down the line, and they you know, so it really runs the gamut in terms of the level of knowledge and experience there. And that, you know, that is definitely something that we need to educate the organization with, and partnering with the right people, not the IT people, right? Again, it's a business problem. To back to the original survey. So more on, you know, what we should be doing. So again, I just, you know, the NIST NIST cybersecurity framework is a very good, easy to understand architecture, which aligns even in this space, although there are differences in the IT and the OT area. So identifying your assets, once again, that's much different than in the IT area, right? So you have maybe 10, 15, 20-year-old machines there. You know, doing a network scan, you could take down the production environment very easily. A 10, 15, 20-year-old machine, just the act of scanning it can bring it down. So, you know, so that's kind of out. Installing agents on devices to maintain inventory, that's out, because very oftentimes you can't install an agent. So, you know, in the OT space, the only real way to address this is through passive discovery methods. And there are, you know, any number of vendors out there that that'll do this, but I mean, identifying your assets, again, has got to be step one. Knowing what you have, understanding the dependencies. I mean, if a manufacturing facility really did a proper, you know, business continuity plan or business impact analysis, they should at least have mapped out the dependencies of these operational technology machines they have in their environment. You know, different levels of that being done still, but you know, the protect aspect. So, you know, the old air gap concept, you know, although it's sort of dead, doesn't completely go away. There needs to be a level of separation, because again, you've got a different risk profile in that OT environment just due to the nature of the machine. So this is where general controls come in, access into that environment. You know, our third parties able to come in and stick a USB into a device. You know, that's a potential vector of attack on some of these machines, the physical. So, you know, looking at physical and logical access controls in the machines in that environment, right? Detect and respond in the OT space, again, also different, right? The IT approach of putting an agent on there where you can take action on an endpoint is often cases not feasible. So, you know, addressing this through regimented access control, you know, least privilege on these machines, so that when, you know, inevitably if something does happen, you can reach a level of containment there and mitigate the damage. So a lot of work to do in this space. I mean, I must say, even and within Magna, I mean, this is actually one of our top priorities this year, is to sort of, you know, bolster our defenses in this area. I sit on a couple of executive business councils on this particular area, and I can tell you, automotive's not alone here. I mean, you know, our friends in oil and gas and other manufacturing verticals, they're suffering the same challenges. Yeah, it just, I think probably the number one thing we need to do here is really really educate the business that nowadays cybersecurity translates directly into potential downtime for your OT environment. I mean, that's where you start that conversation, right? With this area. So hopefully that answers your question, AJ.
Yes, that does. And I can see, as you said, a lot of work is required in this area also. And today's discussion highlights that, whether it is OT cybersecurity, or it is on the hardware security side, or if it is cyber incident management, the threat detection, legal. So a lot of work is required here. And that's where Windsor-Essex is taking a leading role. It's becoming the automobility capital of Canada. Can you tell us a bit more about the various initiatives around cybersecurity in Windsor-Essex?
Yeah, absolutely. Thanks, AJ, for that segue. You know, there's certainly, I mean, anyone who's in the region will know that there are a number of initiatives happening around automotive cybersecurity and around automobility specifically. You know, what we've developed in the region is more of a holistic approach as we look at automobility and cybersecurity being one big facet of that, instead of looking at things from a piecemeal perspective. So, you know, building programs and supporting the changing automotive landscape and supporting our journey into automobility are all key things. And so some of the things that, you know, come to my mind, first off, I want to absolutely give a big shout out to you know, Dr. Mitra Mirhassani, and of course, Dr. Ikjat Saini, for the development of the Shield Automotive Cybersecurity Center of Excellence. You know, you got to hear what, you know, Dr. Mitra said about, you know, training and some of the gaps that they hope to fulfill and make sure that we have the talent pool. So, you know, Windsor-Essex being such an automotive and automobility hub, that's going to be crucial moving forward. So from an R&D perspective, from a training perspective, you know, the Shield is going to produce some amazing results, I think, for the region and clearly beyond. Also, on somewhat of a same note, when we think about, you know, St. Clair College, our other academic institution in Windsor-Essex, they're working on a 6-month micro-credentialing program in cybersecurity, and don't have too many details on that yet, but obviously stay tuned for that. So that's going to be crucial. You know, as you have professionals working in the field already, you know, they need training and they need it quicker than those that are able to be in longer programs in school. So that's going to be very key for filling some of that gap. You know, I know it was mentioned in the chat, but I'll mention it again. You know, WeTech, in partnership with WEDC, you know, we're working on launching the cybersecurity path, you know, generating a plan for the future of Windsor-Essex and even Chatham-Kent. And so when you think about cybersecurity, there are plans in place, and there's a report and a strategy in place that will be shared shortly. And just in general, when you think about automobility, we have so many partners in the region that are kind of working and singing from that same book. So we have, you know, like, for example, the Windsor-Essex Regional Chamber of Commerce, you know, they have the automobility membership program, and there's a lot of crossover and collaboration that exists there. We have Workforce Windsor-Essex helping from the talent development standpoint. You know, you have our trade associations locally, you know, you have CAM and Automate Canada, and so many others that I didn't get a chance to mention, you know, when I first when I brought the remarks. But you know, I just want to say that as a whole, as a region, you know, we're definitely on this amazing journey in this what we're dubbing as automobility and cybersecurity. I mean, we can tell today it really touches on so many facets, and we're excited to move forward. So, you know, we're happy to have you and your company here, AJ, and we know that there will be many more. We hope that join, and we'll get a lot of resources out of the Windsor-Essex region.
Yes, I feel the kind of initiatives which are there and the kind of support which is there for cybersecurity. We will not have one company around automotive security. We'll have 100 companies, and all will be global leaders. And I do hope that Vehiqilla will be part of that journey, because this is very exciting, and a lot of stuff is happening in Windsor-Essex. I think that does bring us to the end of our panel discussion, and we can move to the questions which we have. I do want to begin with something which was mentioned around the percentage of cyber attacks that are non-email related. So Rob, maybe over to you if you can answer that one.
Yeah, I guess it depends a little bit on who's doing the attacking. If you're looking at cyber criminals that are coming in and what they want to do is somehow get money from you, that's certainly the highest in terms of raw volume. As I say, the one number we had was a study done by IBM last year of their Canadian companies that they are aware of that got hit, and it was 60% of them were done by ransomware, and almost all of those come in through email attacks. The same as through business email compromise. It'll start through that as well. So in terms of raw numbers, that's what's in there. But if you look at some of the recent attacks that have gone on when they're being done by nation states, where they want to go in and maybe actually get information from you, but not so you're not aware that it's actually going on. They want to steal intellectual property, understand what your capabilities are, where you're going. And I'm thinking back through on the SolarWinds attack underdone by a nation state. In that instance, and Dr. Mirta talked about that, where you're actually, in this case, it wasn't hardware, it was software with that same implants actually in the equipment, in this case, the software you're buying. So you've brought the software yourself into the system, and it's corrupted. It's got some ability inside it for the attacker to get the information outside your system. And what they're trying to do is to do it in such a way is you're not going to become aware of it. But so again, it depends a little bit on who the attacker is. If it's a criminal, by and large, it's going to be through email. If it's a nation state, it's going to be things like, you know, they've manipulated the source code on something that you've got. They're going to come in at it slightly differently, and they'll do it over a longer period of time. The SolarWinds attack was underway. The background to that was underway for about 6 months before they actually got inside the system. And they think it took, I was speaking with the president of FireEye, and he thought it would have taken about 1,000 analysts, researchers, people writing code to actually do that attack. So this is not a small undertaking.
I think that definitely, and thanks for mentioning the nation states. That's when we start looking at the automotive infrastructure of a country, that's critical infrastructure, and definitely that could be impacted by large-scale cyber attacks. That has to be looked at. The other question, which was probably kind of related to what you said, Robert, earlier, it says, does this mean that the display of VIN to be moved out of sight instead in the windshield? So I think that's related to what you said about Europe and VIN.
I'm sorry, could you? I didn't quite get the question, AJ.
Yeah, the question was, does that mean that the display of VIN has to be moved out of sight instead of in the windshield?
That's a really good question, and the research that I was looking at didn't actually say that, but that's going to be an interesting challenge, because and I think I'll call it the laws and the regulation are so new on it, and there's been very little case law on that to decide what actually takes place. I don't know in that particular instance whether just the VIN number in and of itself. They say that that's going to be personal information. So if you stuck personal information on the windscreen, then I'm not a lawyer, but somebody might argue that that's actually personal information you stuck on the windscreen. And I can see lots of problems in a variety of ways for that coming through. And again, this is right. These are regulations that have literally just arrived on the doorstep. I think the one from California again was in November. So it'll be interesting to see how that actually gets rolled out. And more importantly, how does it get enforced? And how are they actually going to do that? And then what's the case law that's going to come out? And how are the courts actually going to interpret that?
I think related to that, an interesting law has come out in Massachusetts, and that says that the data in a vehicle is owned by the owner of the vehicle. So the driver or the person who's purchased the vehicle owns that vehicle and should have access to that data. Now that opens up a totally different area from a legal perspective also, that if I as the owner of the vehicle can go in and change any data, change any configuration of the vehicle, how would that impact the vehicle itself and the functioning of the vehicle? Peter, do you have any insight into that? Is that kind of like if whatever data is in the vehicle is available to all the owners of the vehicle, the consumers of the vehicle, how would that impact the manufacturer?
Oh, that's a very good question, AJ. And so no, I don't have a good answer for you. So I know I can tell you, we have Magna, we've got very diverse lines of business, right? So if you look at our, sort of our electronics group, powertrain group, we've got seven different lines of business. So very diverse. And this is something that we struggle with. I mean, as you've mentioned here, we've got several of these new pieces of legislation that have come through. They impact our different lines of business differently. And I mean, I know at this very moment that our legal department is still kind of interpreting what the impact is going to be on our various lines of business, because one of the questions that keeps coming up is, as these types of legislation come out, who is ultimately accountable? Is it the OEM who really delivers the finished product to the consumer, and what level of liability would, let's say, a tier one like ourselves have in that space? For the most part, our interpretation is largely it's so I've heard, right? So again, this stuff is very new, but largely the finished product delivered to the consumer with the banner name on it from the OEM. Ultimately, the OEM has accountability, but there's no doubt that tier ones, tier twos that are either writing code, manufacturing these components are going to have a level of liability. Honestly, the legal departments are still figuring this out by and large. So that's the best that I can give you right now.
Yeah, and I think it will become very interesting because we have to start thinking of the vehicle as a platform.
Absolutely.
Like it's your smartphone, and there will be developers who would be developing stuff on that, and I could maybe develop things on my own and have it on my car. So it would become very interesting. So I do have another question. It says we have discussed about how a company can help protect itself against cyber threats. What advice can you give to a consumer in order to better position their privacy, especially so cars become more connected? Dr. Mitra, do you want to take that one?
I'm still thinking about the previous question. I actually don't have a straight answer about that. I just say that we have to be basically from the perspective of cyber resilience or cyber security, or what I try to call it now, auto security, and drop the cyber from it anymore. There are many new domains that are now entered in the field. We are just discovering. So I say that, for example, if we are talking about the organizations that have or gain financial benefits, or their livelihood, it depends on it. I say that there has to be a mechanism that repeatedly reviews and basically examines the company benefits with regards to the cybersecurity and newer issues that are popping up. The era of designing certain protocols and just going based on that for years and years is basically done and gone. And any organization has to be agile enough and be on alert for newer cybersecurity issues that are popping up. So revision, constantly being in the loop, getting to know more about the news. Those are some of the things that I think an organization has to be very careful about and look into it. Also, there are, for example, certain attacks that used to be, we wouldn't think about it. Now, by example, they would be applicable to the corporations. So I guess that any organization in this new environment, in this new ecosystem, has to be very, very alert about the new securities and keep revising and reviewing your policy and procedure.
Sounds like we have to have a automotive cybersecurity awareness program for all drivers out there, all owners of vehicle. That might be an interesting program. Whoever has a connected vehicle needs to understand the cybersecurity aspects of that. Just as we understand that we have to have an antivirus on our computer, or we have to not click on phishing emails. So there is a program out there on that.
Maybe more than what the cell phone owners do, because because now we post our pictures and information just freely on the web for whoever wants to view it. We probably have to make sure that the car owners know more about the issues of privacy and security than cell phone owners.
Exactly. I do have another very interesting question here. So it says, within the existing automotive ecosystem, can you discuss the prevalence of cyber attacks on vehicles and highlight maybe the last 2 or 3 major breaches that you are aware of? Who wants to take that one?
Usually the Tesla ones are the ones that keep getting mentioned. If you're talking about the cars, I unfortunately I don't remember the whole exact details because I kind of it's been very busy with the teaching and establishment of the Shield Center, but I think there was a report that a car owner of a Tesla basically hacked into the system of his own car and then posted all of his results and information on the web for whoever wants to access and see it. So that is one of the first examples that comes to my mind, and I'm sure it was pretty much in less than 2 months ago, 3 months ago, if I'm right. I don't know if you guys remember that, or am I off the?
Yeah. So there has been a recent one, but the one which I would like to mention is the one with Jeep Cherokee, which is a bit old, but we all know that there's a nice video of it on YouTube. So, and a cybersecurity researcher actually goes through the process of how that was done. The interesting thing is it led to a huge recall, I think 1.4 million vehicles, and that shows the impact of cybersecurity breaches. Another one which I do want to mention these days from a trucking perspective is attacks on ELD, electronic logging devices. So that's another one which is out there right now. As Robert mentioned, there has been ransomware attacks on automotive manufacturers. So those are there also. So there are a number of different attacks which are specifically on the automotive sector and have been highlighted in the media also.
I mean, ignition systems as well, right? I mean, that's a fairly recent one. They just broke up an automotive theft ring that was stealing vehicles of a particular manufacturer, I guess not named, and stealing vehicles without keys and loading them on shipping containers and sending them overseas where they could get top dollar for them. So, I mean, this is a form of cyber attack. They are stealing these vehicles without the keys, and they're basically, they're being able to circumvent the ignition control system of very popular vehicle brands. So quite.
I have to Google it to find the name.
One of the things that we noticed sort of through the whole COVID pandemic is how adaptable cyber attackers are to taking advantage of the situation. So I think it's pretty reasonable to assume that as we move more and more into autonomous vehicles, that the cyber attacker is going to be very creative in coming up with more and more ways to go after and start to do the attacks. And the interesting thing is going to be, it's not going to be just restricted to the automobile, to the manufacturer, or the sort of wherever they are in that supply chain. All of a sudden, me, Bob Gordon, as owning a vehicle that's now a computer that happens to have 4 wheels on it, is another place that can be attacked. So some of those ransomware attacks could actually be directed down to the level of the individual. That's me. So what am I doing to protect my car from a cyber attack? Are there some things that I should be doing? Or when I'm starting to enter things into my car, because my car is likely going to have some kind of a connection back to the internet, am I increasing the vulnerability of my car because I'm clicking on something? And I guarantee there's going to be a cyber attacker out there that's going to be trying to think of what are all the creative ways that I can elicit money from anybody in that continuum, whether that be a supplier at the one end, the manufacturer, or the user at the other end, because they don't care which one they're going after. It's who's going to be willing to pay the money. And it comes down to me being able to get into my car. Would I pay them $200 on a windy, cold night in Ottawa to get back into my car? And the attack comes in on my cell phone saying, I can't use my cell phone now to get into my car. I guarantee I'm going to pay.
Very interesting. And actually, these similar scenarios have come up in a new question, and I do compliment the questioner here. So the question is how to protect against these automobile specific attacks. So the first one is Assassination 2.0. It says cyber assassin hijacks a car with you in it and crashes the car. No cop will ever request a forensic investigation of the source code and thus classify the murder as the cop will not classify the murder as an accident. So that's a very interesting scenario. And I think from legal, from insurance, from criminal perspective, these are the kind of scenarios we have to look at it. There are 2 other scenarios, but before I go there, does any one of us want to take up this one?
I think this is more Robert, right?
Well, it's certainly going to be an interesting legal question. I mean, if you think about cybersecurity just broadly, so one of the things that law enforcement is having to wrestle with is cyber attacks have now become the new form of fraud, new form of a lot of crime. So in the smaller municipalities, they're having a tough time trying to deal with those kinds of crime. They don't have the resources, the technical capability, some of the things that Peter was talking about, certainly do not exist in some small towns. So if that's the kind of attack that a small municipal police department is having to deal with, yeah, I would agree with your questionnaire, whoever asked that question. The chances of somebody going through and saying it was the car that was at fault as opposed to my inability to drive down the road, yeah, it's not likely going to happen, which then puts more onus back on the system to try to make sure that all the securities are in place to protect me from that kind of thing happening, because I can't possibly do anything about that, and neither can some small municipal police force coming through to look at the crime after the fact.
Yeah, and
I was just going to say, if Mitris within a lab are having a hard time trying to identify, adjustments made or things done to a piece of hardware, that's going to be a tough one for anybody else forensically to be able to do in the way they would normally conduct an investigation of what's otherwise just another automobile accident, of which there was thousands yesterday.
I say from educational point of view, the same as the car repair shops traditionally were mostly mechanical. Now we need computer programmers in a lot of those areas of car. Maybe the forensic and workforce is another one of those fields that needs to get updated skills and add C programming or programming in general to the required skills and requirements. Yeah, that's actually a very nice and interesting question.
And then we have another one, which is ransomware 2.0. When mobile payments will become ubiquitous, cyber mafiosi hijack your car with you in it and drive wildly to scare you. Then they force you to pay, or they will crash the car with you in it. So another very interesting scenario there.
I'll pay. I want to go home. I'll pay, definitely.
Yeah, and then the last one, I'll just mention it, adversarial attacks. So quit adversarial attacks against the autonomous cars AI. For example,
Oh.
human sees a stop sign, but AI car sees a 45 miles per hour sign.
Oh, that's very easy. I mean, we used to, and I kind of alluded to that, we are kind of trusting the AIs to be secure, but AIs are one of the most vulnerable parts of the vehicle decision making. You can easily fool them, especially the ones that rely on visual cues, as this question is, also referring to. You can easily basically force them to get fooled, and instead of seeing a pattern or certain objects, see something different, interpret the data differently. That is, I should see who asked these questions. Edward, I'm with you on the third question. We actually are looking at this issue, and this is also one of the very widely open, unanswered areas and scary parts of automotive security that you can easily fool and get out a different outcome out of an AI.
Yes, I do feel that, Edward, you've got some great scenarios there, and these are the kind of things we have to be worried about. I'll give you another scenario. A hacker takes over 10,000, 20,000, 100,000 vehicles, and we has the whole jurisdiction targeted. How would you look at that? So it's not on an individual basis, it could be on a country basis also, and so it's a huge challenge, and we have to not only look at it from the technology perspective, we have to look at it from a process perspective, we have to look at it from a legal perspective, we have to look at it from a criminal and forensics perspective, and all of that, and also from an insurance perspective, all of that work has to be done. So there's a lot of work over here, and I think today's panel shows you that how much work and how many challenges there are. But on the flip side of it, I would say those are the opportunities for automotive cybersecurity SMEs, and we can work towards that to enable a secure mobility sector. So I think we'll stop over here. Ed, over to you.
Thanks, AJ. So I just wanted to thank everyone. I want to start by thanking you, AJ, for moderating this panel and providing an excellent presentation and overview at the beginning. You know, today is day 3, Tech Mobility Day for YQG Tech Week, and we're very excited to have this amazing and distinguished panel. So to you, to Dr. Mitra Mirhassani, to Mr. Rob Gordon, and to you, Mr. Peter Elliott, thank you very much for participating in this very informative session. There were a lot of great things that came out today and a lot of thoughtful pieces. You know, this is one topic that has a lot of information and a lot of different scenarios and ways to look at it. So, you know, I think it's an ongoing and a really important thing moving forward in the automobility realm, as we're calling it. And we're very grateful for you all to be able to participate and take a few hours of your lives today and educate everyone. So thank you. And just with when we finish off here, so anyone who'd like to stay on, you know, we do have an optional virtual VR cave demonstration. So of course, with COVID and the pandemic happening here, you know, we would have loved to have everyone. Usually Tech Mobility Days are bustling at the IBLS building, but of course we can't do that this year. So myself and our VR caveman, Akash Charavila, we put together a video and a demonstration on the M-City test track. So I'm going ahead and I'm going to run it. So it's only about not even quite 11 minutes long. So if anyone would like to stay and watch, I have my contact information. Please reach out to us anytime if we can work with you and bring you into the VR cave. We'd love that as well. So that's it from me. Before I run the video, AJ, is there anything else you'd like to add?
No, I just want to thank you and thank everyone on the panel and to thank the audience. This has been a great discussion, and I think let's move the cybersecurity conversation forward in Windsor-Essex, and let's make Windsor-Essex the automobility capital of the world with respect to cybersecurity.
I can stand behind that and second that. Thank you, everyone, for the opportunity.
Thank you very much.
Thank you.
Thanks, everyone.
Bye-bye.
Thanks, everyone, and thanks to our sponsors. So stay tuned. I'm just going to go ahead and run the video for anyone who's interested.
Hello, everyone, and welcome to Canada's largest publicly accessible VR cave here in Windsor-Essex. My name is Ed Dawson. For anyone who doesn't know me, I'm the Senior Manager of Automobility and Innovation as part of the simulation team. And this is...
Hello, everyone. My name is Akash Charavilla, and I'm the engineering analyst at the VR Cave.
We're very excited today to be able to provide you a demonstration of one of our premier test tracks that we have available here at the VR Cave. This here is the University of Michigan's M-City test track, and we have a complete digital twin of the testing facility here available at the VR Cave. So I'm going to turn this over to Akash, and we're going to take you through a demonstration to show you some of the features of what are available as part of M-City in a digital format, and why it's important as we move forward when we test both connected and autonomous vehicle technologies and other important technologies as it relates to automobility.
So hello, everyone. This what you see on the screen is the digital twin of the M-City test track. So this test track was designed for testing of connected and autonomous vehicles, and we have a digital twin of the test track for simulation of different technologies for connected and autonomous vehicles. And how we created is we actually did a LiDAR scan of the entire area, and we created a point cloud model that was then used to create a VR experience file that allows you in the simulated environment of M-City. And because it's a simulated environment, this allows us to create different scenarios for testing different products. For example, if you want to test your camera on how it performs in low light conditions, that can be done. We can change the weather. We can introduce different actors, pedestrians. We could change traffic scenarios, and this really allows you to test different conditions for your self-driving product. Let me give you a bird's eye view of the track, and let's just focus on a few areas of the track before we get into a car and go on a virtual tour of M-City. So as you can see, as I mentioned, it is a LiDAR scan that helped us create this environment, and it is a very true to life, very accurate model. It is accurate up to 2 to 3 millimeters. And as I zoom in on different areas, you could see how we have the detailing on the road, we have the lights, the traffic lights, the stop signs, the pedestrian warning signs, and all other elements that the actual test track has. And this really allows you to test your system in a virtual environment and then go to the actual test track. And because it's so similar, you could evaluate how your system performs in an actual environment. And then if there's any rework required or any improvement that's required, you can always go back, test it in the simulated environment, and ensure that it performs perfectly well on the actual test track. So I let Ed jump onto the driving simulator and give you a drive through around the test track.
So I am in the driver's seat, experiencing as if I was in a self-driving vehicle going around the test track. So we are bound to experience some issues just to see how the vehicle may react.
The software that we use in the VR cave is called VR Experience, and this is the driving simulator module of the software. And this software allows you to test sensors, LiDARs, cameras, the perception algorithms, and different safety algorithms that a self-driving car would have in a safe and simulated environment, and really test those edge cases to see how your system performs under different conditions. So as you see, Ed's in the driver's seat, but the car is driving around itself, and following all the traffic signs. It is following cars in a very safe environment, and you could test these edge cases. Um, and this is and this is probably this one of the issues that you would encounter in a self-driving car as it's trying to react to different traffic conditions. And this is the best example of why simulation testing is the best way to go as you are in the initial stages of product development, because you can test your product in a safe environment without any damage to property or your test vehicle. And you could test out different situations, identify the issues, and iron them out before you actually go onto the actual test track to test your vehicle. And this is just one of the examples that what we can do on the test track. As I mentioned before, you could test different conditions of weather, different conditions of lighting. So it could be a low lighting condition, and if it rains, you can perform simulations to understand how your system would react to these situations. You could also bring in different actors. By actors, I mean pedestrians and different types of cars. So we have trucks, buses, we have motorbikes, bicycles. All these can be brought into the simulation environment, and then you could train your perception algorithm, for example, to how to identify different objects, and then how to react to these situations. And we have a repository of test tracks. So we have, not only do we have MCity, but then we have a good mix of city and country roads, and we are also trying to include more test tracks in our database. So right now we are working with AreaX.O from Ottawa. AreaX.O is a test track designed for CAVs, and we are in the process of getting a digital twin of AreaX.O created, so that we could leverage both the test tracks, the test track in Michigan and test track in Ottawa, to test CAVs both across the border.
Thanks, Akash. So you can see, just sitting here is very unique to be able to see what would happen if the vehicle reacts appropriately or if it runs into any issues, whether from its own system or other vehicles leading into its way. So there you have it. You have a little experience virtually of what a test track looks like here in this large scale VR cave environment. And Akash mentioned it earlier, but we are currently working on, of course, 2 new test tracks. One that we're very excited about is the Windsor-Detroit Tunnel, the first ever border crossing to be simulated for a virtual environment like this to a true scale. And that's going to be very important for us because one of the focuses that we have here at the Windsor-Essex Regional Technology Development Site as part of the Autonomous Vehicle Innovation Network are cross-border technologies. And of course, challenges will always occur because you can't just test equipment and or hardware at an international border crossing without many approvals. So what we have the opportunity to do here is to be able to test a lot of these different pieces of equipment in a simulated fashion, and of course, run different testing scenarios. So that's one of the exciting projects that will hopefully be done potentially by the end of the summer. And of course, as Akash mentioned, simultaneously, we're also working on the test track in Ottawa, known as AreaX.O. So we're going to have a Canadian equivalent to what's happening right across the border in Michigan. And the idea is to have a whole compendium of different test tracks available. So if we are working with companies that are looking to test a variety of different scenarios or situations, then they can certainly choose from the test track that they want to use, the different obstacles that they want to add, the different weather conditions that they're looking to add, and a whole bunch of other opportunities. And even from a cybersecurity standpoint, when we think about automotive cybersecurity, using the driving simulator, you can add a lot of different scenarios. So, for example, You saw how the bus decided to cut in front of the vehicle and literally destroy the vehicle as I was riding in it. But these are things that you know, as a human, and you're sitting in a driving buck, you can experience and see how to react. So there are many benefits of having a simulation environment of this caliber. And you know, we're very excited to be able to work with companies that are in the CAV space, and companies from our digital twinning program that are looking to utilize some of these technologies, you know, to twin a product or a process. And you know, please reach out. You know, Alkash and I are here. There's also another team member that recently joined our team, Lindsay Pasil, and she's working on our digital twinning program. So we're a team of three, and we're very excited to welcome, you know, new opportunities and talk more about the VR Cave. So please feel free to reach out to us. You know, we have a website, Wavin, WAVIN.ca, and then there's a lot of information on there. And then you can also email me, edawson@choosewindsoressex.com. So thanks very much from Akash and I. We want to thank you for tuning in, and we look forward to speaking to you again.
Thank you, guys.
Well, thanks everyone. Hope you you enjoyed that. Next thing from being really there, and you know, this is an opportunity. We're hoping that next Tech Mobility Day 2022 and 2021 will be at the VR Cave in person. So everyone, wishing everyone a great day, and please reach out. You have my contact information if you'd like to find out more about the VR Cave and how to work with us. So everyone, have a great afternoon, and thank you for participating today.